In section 1.1, we developed a system to represent and to write our whole numbers. Now, if a system or a notation is any good, it's actually going to be very expandable or extendable to other kinds of numbers. What we don't want is a situation where, well, if we're talking about natural numbers, then we're going to present them this way. But then that's going to stop working as soon as we introduce decimals. Or wait, that's going to stop working as soon as we introduce negatives. Or that's going to stop working as soon as we're talking about fractions. So remember back to your math classes, a situation where you would do something that made perfect sense. And then the teacher would say, yeah, but that only works for negatives. Or that doesn't work for negatives, right? So those kinds of situations are examples of where a notation or a procedure is used and the procedure is not strong enough to handle representing different kinds of numbers. So that usually means that procedure is not a good one to be introducing to students. So we're looking for those procedures or models that are actually quite extendable to different kinds of situations. So let's take a look. If you allow me, I'm going to stick with toothpicks. They're much easier to draw. So it's asking us to now use toothpicks to represent these numbers. Now notice they're less than 1. We're now in decimals. 1 toothpick stands for 1,000th. So we're going to have tiny slivers, toothpicks, and each one of these is 1,000th. So how many thousandths do we have? This is our 4 thousandths. So we should have 4 of those loose. What does 3 stand for? Well, 3 stands for 300ths, and the 100th is a bundle. So we would have 10 of them bundled up to make 100th, and we have 3 of those. How many tenths? There are no tenths in this number, but if we wanted tenths, those would be the Ziplocs, the 10 hundredths. In the second example, we would have 4 thousandths, 3 bundles, and 1 Ziploc, where there's 10 bundles. So this is our 1, that's the 3, and that's the 4 loose ones. So notice that the structure of the modeling is staying the same. What's changing is the meaning of that single toothpick. So what if we need to model 0.13 with each toothpick representing 1,000th? So how many is there going to be 1,000th or 2 or 3? Well, in fact, there are not going to be any thousandths, but we still do have the 3 hundredths and the 1 tenth. Right, and that's going to be nothing in there. So notice whether our 34 is just as a 34 represents 34 3 tens and 4 singles, or 34 thousandths, which is 3 hundredths and 4 thousandths, or 34 millionths. It doesn't really matter. This diagram is going to be the same. It's just going to be representing a different number because the meaning of the toothpick is going to be different. So I'm going to leave number 2 to you, and they're asking for beads, but feel free to represent them with toothpicks as well, just for simplicity of drawing. So if you have each of the units or each of the toothpicks or beads is 10,000th, then how would you represent these numbers? Number 3, let's list at least 3 different decimals that the toothpick pictured here could represent. Well, what are the digits? So we have 7 and 3 and 1. So we have 7 loose, 3 bundles of 10, and 1 bundle of 100, or super bundle. We would put that into a Ziploc. So that could be, if the 7 is representing the ones, that could be 137. But what if the 7 is representing the tenths? If the 7 is representing tenths, then what is 10 tenths? Those are ones. So 3 ones and 1 10. What if the 7 is representing 1,000th? Then we'd have 3 hundredths, 1/10, and 0 ones. Could we have something like this? Sure. We're going to skip doing this. You can if you'd like. The materials are in the back of your book. You can make a copy and cut them up. What we're going to do is we're going to really take a careful look at if a student was asked to place tenths on this number line. So imagine that this whole number line is 1, right? And if we have tenths, it would have been made up of 10 toothpicks lying side by side. So if we were to show the 10 toothpicks, then we would need to use tick marks to show the ends of the toothpicks. And let's see if we have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. All right, so there are 10 toothpicks lying across. What did this student do in the bottom? He said students put 10 tick marks between 0 and 1. So how many toothpicks did they make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 toothpicks. They've actually grouped 11 toothpicks into one bundle. I'd like you guys to really think about it and figure out what's wrong and how do we speak about the number line to try and prevent this problem from happening. Okay. Now, based on the way that we've created the number line, let's just check. Between 3 and 4, there should be 10 toothpicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So there are 10 toothpicks between any of the larger tick marks. So if we look at the tick marks, as soon as we start looking at a number line, we have the 3 and the 4, and those were large tick marks. In between them, we're going to be splitting into tenths. These smaller tick marks that we're using are actually different place value. So the large tick marks were the ones, and the small tick marks are the tenths. So if we were going to say, well, 3 ones and 1/10, 3 ones and 2/10, 3 ones and 3/10, 3 ones and 4/10, 3 ones and 5/10, 3 ones and 6/10, 3 ones and 7/10, 3 ones and 8/10, 3 ones and 9/10, and then we have 4 ones because we'll be able to bundle up the toothpick. Now, if we were going to zoom into this toothpick, right, then that toothpick would say that this end is 3.2 and this end is 3.3. So the large ticks and the small ticks actually mean different things. So the large ticks in this number line are tenths and the small ticks are hundredths. So for example, if we zoomed in, this would be 3 wholes, 2/10 and 1/100. 3 wholes, 2/10 and 2/100. 3 wholes, 2/10 and 3/100. 4/100, 5/100, 6/100, 7/100, 8/100, 9/100. And then 3 wholes and 3/10. So now what if we wanted to zoom in here? So that would be 3 wholes, 2/10 and 9/100, and 3 wholes, 2/10 and 10/100. 3.210? It's not going to work quite that way, so it's that we're actually going to regroup into 3 wholes, 3/10, and 0/100. These large tick marks are still representing hundredths. Large, small. On this, we're going to be hundreds for the large, thousands for the small. So let's try to label them. 3 wholes, 29 hundredths, and 1 thousandths. 3 wholes, 29 hundredths, and 2 thousandths. 3 wholes, 29 hundredths, and 3 thousandths. And now if we're zooming into here, we would see 3 wholes, 29 hundredths, and 9 thousandths, to 3 wholes, 29 hundredths, and 10 thousandths. Except that's not how our number system works. We would regroup to 3 wholes and 300 thousandths. The large would be our thousands, and the small 10 thousandths. So if we were to zoom in even further, we'd have 3 whole, 299 thousandths, and 1 10 thousandths. 3 whole, 299 thousandths, and 2 10 thousandths. What do you notice is the difference between large and small tick marks. And is that meaningful? Is that helpful? What if we were asked to plot 3.2996 on each of the number lines in part 1? So if we were to plot it here, this is our 3 and this is our 4. Right? We're greater than 3, less than 4. And if we were able to split our number line into tenths, so we would imagine splitting that number line into tenths, then our number would end up almost 3 tenths of it. If we were between 3.2 and 3.3, well, we're between 3.2 and 3.3. How close are we to 3.3? We're very close. We're 9 hundredths close. So we would probably end up somewhere in here. How about on this number line? Our number is 3.29, so we'd be able to put it somewhere in here. And how close is it going to be to the next tick mark? Well, we're 9 thousandths. So we would be right in here, really close to the other edge, even closer. Okay. Now 3.29, 3.30. So we would be at 3.299. So it'd be between here and here again. So we're at 6 10 thousandths. So we would just be just on that sideline, on the right of the middle. And now in the last example, we actually have a tick mark in that spot, because we zoomed in enough for that number to land on the tick mark. So this is an excellent way to move from the toothpicks by laying the toothpicks out end to end, and then being able to zoom in and out as many times as you need in order to be able to place that particular place value. So let's take a look now if we could imagine where these numbers would fall. Which whole numbers does 3.2996 lie between? Right? And you go ahead and flip back to look at your number lines if you'd like, but we're going to try and make sense of it without those number lines. So which whole numbers is it between? Well, it's greater than 3, and it's less than 4. Okay, so which tenths does it lie between? So it's between 3.2 and 3.3. Which hundredths does it lie between? It's between 3.29 and 3.30. So it's between 29 hundredths and 30 hundredths. So label the tick marks on the next 3 number lines in 3 different ways. In each case, your labeling should fit within the structure of the base 10 system and the fact that the tick marks at the end of the number lines are longer than the ones in between. may help you to think about zooming in and out. I'll give you one hint. If we're looking at this 4.9, if we're saying that this is tenths, right? So there's 9 tenths here. The previous tenths tick mark should have been 4.8. And you should be able to then name the ones in the middle. So 4.81, etc. But if we're looking at this as hundreds, if this is 90 hundredths, then what's the previous hundredth? It's 89 hundredths. And then I'll ask you to label the thousandths in between. What if this is thousands? So it's actually 900 thousandths, and the previous thousands would be 4.899, 899 thousandths. And then you would have the ticks in between. So notice that as before, we have the long tick marks or the large tick marks mean one place value, and the ones in the short ones, the little ones in the middle, are small, the one smaller place value. So if these are tenths, then these are hundreds. If these are hundreds, then the little ones are thousands. If the big ones are thousands, then the little ones are 10,000s. And finally, I'd like you to explain what's happening with this particular student error analysis. So why does labeling on the next number line does not fit the structure of the base 10 system? So what is happening here that is not consistent with the base 10 system? It's often helpful to think about what they do know and what they don't know. And I'm going to leave number 5 to you. So let's take a look at number 1. What number could the point labeled A on the number line be? Along the numbers in the list, which one could A possibly be, and which ones could A definitely not be, and why? So let's take a look. This is 1 and 2. So these tick marks are 1s. We're counting by 1s. So if we were to use the tenths tick marks, right, in there somewhere, yeah, let's say 10ths tick marks, then is it possible that A is 1 and 1/10? That's not possible. Is it possible that it's going to be 1 and 8/10? No, because that would be over here. Is it possible that it would be 1 and 6/10? No, because it's on the wrong side of half. So now, is it possible that it's going to be any of these? 1.39, 1.5, and 1.4, 1.4263, and 1.43. Okay, so I've put it on the 4th tick mark. Could that actually be the 1.4? Right, I was only able to put it on the 4th tick mark because those got a little scrunched. So really the 4th tick mark should be somewhere closer to the left. So if I were arguing this, I would say that it's one of these two and not this one, and unlikely that one. In number 2, let's see what we can think about here. So label the tick marks on the following number lines so that the tick marks fit with the structure of the base 10 system and are as specified, and so that the given number can be plotted on the number line. The number need not land on a tick mark. So the long tick marks have to be whole numbers. So what whole numbers does this number lie in between? Between 23 and what's the next whole number? 24. And then tenths for the short tick marks. So it would be 23.1, 23.9, and 23.84 would land us somewhere here. All right, so how about long tick marks being hundredths and short tick marks being thousands? So we're at 300ths and more. So we're going to be between 300ths and 400ths. So we're going to be 300ths and 1,000. Okay, So where would our number land? 3, 4. Somewhere really close in there. So long tick marks are tenths and short tick marks are hundredths. So tenths. So what between which tenths does this lie? Between 0 tenths and 1 tenth. If we do that, this is 100th, 200th is going to be somewhere in that region. And I'm going to leave the last number for you to work through. We need to label the tick marks and just figure out which numbers will go on the longer tick marks and which numbers will go on the smaller tick marks. This number is on the 1, 2, 3, 4th small tick mark. So what could those tick marks be? And there's only one digit that could mean 4, and that's 4 10,000ths. So this would be 9.6163. This would be 6165. So if we do that and follow our logic back, this would be 9.616 thousandths, and this one would have to be 617 thousandths. And part B lands right on the tick mark. So it's exactly that number. So this would have to be 9.6164 10,000ths. And the previous 10,000 to that is 9.6163. So these numbers in between would be 9.61631, 9.61632. Take a look at the next one. We'll just do one more and then I'll leave the other two for you to think about. So this is lying between 1, 2, 3, 4, 5, 6th. So 6th tick mark, and it's about halfway up to the next one. So there's 2 6 digits. If these tick marks were tenths, then the point would be a lot closer to that tick mark. Here, this 4 means that it's going to be closer to the middle. So if we were to name these tick marks, it would be 9.616 and 9.617, and 9.618, 9.619, 9.62. So this would be 9 and 61 hundredths. Okay. All right, and I will leave the last two for you to do. And finally, let's check our model with negative numbers. What we've learned so far: tick marks, long and short, or large and small, and place value. And we also know that numbers grow to the right. So if we were analyzing Katie's work, it would say the -6, -7, -8 are labeled on the ones tick marks. That's fine, right? And there should be 10 spaces, 10 toothpicks in between. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 toothpicks in between, so that works. But what doesn't work is that the -6 and the -7 and the -8 are going from left to right, suggesting that we're increasing, but those numbers are actually decreasing. So in order to correct that, we'd have to switch this -6 and the -8 because they need to be increasing from left to right rather than decreasing. Matt's work, he's saying that -7 is here and -7.1 is the little toothpick. So it would put -8.0 here, which would again be the same issue as Katie's work in that we're decreasing going to the right. So he should move his numbers 7.1 and 7.2 going to the left. Parna's work, or long tick marks, are integers. So if we have -7 there, -8 should be here, and -6 should be there. She is ignoring the fact that these are long tick marks and she's going into the tenths tick marks. You can use these last two number lines to show what an appropriate labeling would be. I will leave number 2 and 3 for you to think about. And feel free to ask questions